Hello students, welcome to this video. The topic of our today's discussion is Introduction to Isotopes. As we have studied in the previous videos that isotopes are the atoms of an element with same number of protons, that means atomic number, but different number of neutrons. They have identical chemical properties but they differ in mass. Understanding isotopes is essential in the fields like medicine and archaeology. Now, what are isotopes? Isotopes are atoms of same element with different neutron numbers. For example, carbon 12, carbon 13, carbon 14. So, carbon 12, carbon 13, carbon 14. The atomic number would be same, that is 6. Here, if I want to find the number of neutrons, we know that this is the mass number, and mass number is sum of protons and neutrons. And these are the number of protons or atomic number. So 12 minus 6 would give me with the number of neutrons. So here the number of neutrons are 6. 12 minus 6 is 6. 13 minus 6 would be 7. And 14 minus 6 would be 8. So here the difference is in their number of neutrons and masses as well. So isotopes are atoms of same element. Carbon 12, carbon 13, carbon 14. All these three are isotopes of carbon. So atoms of same element with different neutron numbers. Isotopes share the same atomic number. That is what I told you here, that they have the same atomic number, that is 6. But they have different mass numbers, 12, 13 and 14. These are mass numbers, so they are different in all these three isotopes. Now, discovery of isotopes. They were discovered in the year 1913 by Frederick Soddy. He explained why elements exhibited slightly different atomic weights. Here we can see that they have different masses, so they would have different atomic weights as well. So because of isotopes, we got to know that how and why elements exhibit different atomic weights. It supported the understanding of nuclear reactions also. Now, characteristics of isotopes. Isotopes have the same number of protons and electrons. So here we can see that they have the same number of protons, 6, 6, 6. And if they have the same number, if they have 6 protons, so they would have 6 neutrons as well, because there is no charge present here. They are neutral. So number of protons and number of electrons are same. Secondly, they differ in their neutron count, affecting the atomic mass. This we have studied. Exhibit nearly identical chemical behavior due to same electronic configuration. As they have same number of electrons, so they would exhibit same chemical properties or same chemical behavior. Stable and unstable isotopes. Stable isotopes, they do not decay over time, because I told you that only unstable nuclei undergo radioactive decay. So the ones which are stable, they do not decay over time. For example, carbon 12, it is the most stable isotope of carbon. Unstable isotopes, they undergo radioactive decay. For example, carbon 14. It is an unstable isotope. That's why it undergoes radioactive decay. Stability depends on the ratio of neutrons to protons. There should be adequate number of protons and neutrons. The ratios should be adequate in order to support the stability of atom. Applications of stable isotopes. Stable isotopes are used in scientific research and diagnostics. For example, oxygen-18. It is used in climate studies and deuterium in biology. It helps us to track the processes without altering the chemical reactions. Without altering the chemical reactions, we can track the different processes that occur. So stable isotopes like oxygen-18 is used in climate studies and deuterium in biology. Now, radioactive isotopes. Radioactive isotopes, they emit radiation. As the name suggests, radioactive. They emit radiations in the form of alpha, beta, and gamma particles. Examples include uranium U-235 and iodine-131 or I-131. They are useful in various scientific, medical, and industrial applications. Now, what are the applications of radioactive isotopes? They are used in cancer treatment. We know that during the treatment of cancer, we use different radiation therapy. So, first application includes cancer treatment. Second, it serves as tracers in the medical imaging. Third, it assists in studying biological processes in real time. In real time, we can study different biological processes using radioactive isotopes. Now, carbon dating and isotopes. What is carbon dating? Here, carbon-14, which is the radioactive isotope of carbon, is used in radiocarbon dating. And what is the use? It helps us to estimate the age of ancient organic materials. For example, there is an ancient organic material. We need to know how old it is. So, through carbon dating, we can get to know about its age, how old it is. And it is effective for objects up to 5,000 years old. Sorry, 50,000 years old. Like, we can determine the age of the objects which are up to 50,000 years old. So this is what we call as carbon dating. Now, what are the applications of isotopes in medicine? First, we have already studied that we can use radioactive isotopes in cancer treatment. Isotopes like iodine-131, it helps us to diagnose and treat thyroid disorders. Then PET scans, it also uses isotopes like fluorine-18 for detailed imaging of the organs of the body. Then it provides non-invasive diagnostic tools for various diseases. Non-invasive means there is no need to insert an instrument and check. Just the radiations are given and it is a non-invasive tool which can help us determine and diagnose various diseases. Applications of isotopes in industry. Industrial applications include detecting leaks, measuring thickness. Isotopes like americium-241 are used in smoke detectors. It facilitates quality control in manufacturing processes too. Now, environmental tracing with isotopes. Isotopes helps us to trace the movement of water and pollutants. The movement of water and pollutants can be traced using isotopes. It is also used to study climate change. For example, oxygen's isotope is used in studying climate change and environmental processes. Stable isotopes provide insights into the natural cycles. Now, safety and handling of isotopes. Proper handling is required and storage should be proper. These two are the main things which should be kept in our mind. Radioactive isotopes require shielding to minimize radiation exposure. Otherwise, radiations are very much harmful to our body, right? So they must be shielded to minimize the exposure of radiations. Training and regulations ensure safe isotope use. Now, what are the challenges with isotope use? High costs, then managing radioactive wastes. It poses environmental challenges. We have to manage the waste effectively. Then it requires advanced technology and skilled personnel in order to store the isotopes and take care of them, handle them. So these are some of the challenges with isotope use, particularly radioactive isotopes. So summary includes isotopes differ in neutron number, but they have same chemical properties and mass. Same chemical properties but different mass and neutrons. Applications include medicine, industry, and environmental science. Safety and cost are critical considerations in isotope use. Stable and radioactive isotopes have distinct roles. So what all did we study in this lecture? First, we studied about isotopes. What are isotopes? Which have atoms which have same number of protons but different number of neutrons and mass. Then we saw an example, carbon 12, carbon 13 and carbon 14. Next, we studied about the discovery of isotopes. They were discovered in 1913 by Frederick Soddy. Then characteristics of isotopes. After that, we studied about stable and unstable. Unstable are those which undergo radioactive decay, that means they emit radiations, and stable ones, they do not undergo radioactive decay, for example carbon 12. Applications of stable isotopes, I told you that oxygen 18, the isotope of oxygen, is used in climate studies. Then radioactive isotopes, for example uranium 235, iodine 131. Applications, they are used in cancer treatment, then they serve as tracers in medical imaging and also to study the biological processes. After that, we studied about carbon dating, in which carbon 14 is used to determine the age of ancient organic materials which are up to 50,000 years old. Then I told you that iodine 131, it helps us to diagnose and treat thyroid disorders. PET scans also uses isotopes like fluorine 18. Then americium 241 is used in smoke detectors. And then I told you about oxygen 18 again, which is used to study climate change and environmental processes. And we can also study the movement of water and pollutants using isotopes. Then I told you about the safety and handling of isotopes, that there should be proper handling and storage. Training and regulations should ensure the safe isotope use, and radioactive isotopes should be shielded in order to minimize the radiation exposure. Then challenges with isotope use: high costs, managing waste is cumbersome, and it requires advanced technology and skilled personnel in order to store them and handle them. So I hope you all got these points. Thank you.